Hello, Algebra 1. Today we're looking at 5.3, interpreting box and whisker plots. And I got to tell you, when I first learned about box and whisker plots was as a teacher. And I thought they were interesting, but I thought they were kind of useless. But then later on, I started taking graduate classes. And when I would look at research, at the back of the research paper, they would have their data, and you would see box and whisker plots describing the data that they collected. And I saw it multiple times, so I thought, dang, okay. So there is a reason that we do this. Box and whisker plot, well, I'll just kind of, you can read through this, but I'm going to go ahead and describe it looking at the picture. So it's called a box and whisker plot because there's a box and then there's these whiskers, a whisker in front, whisker at the end. You don't necessarily have to have the whiskers, but commonly you do. So how this works is you have some data. You have to write your data in order from least to greatest. Your least value is the end of this whisker. Your greatest value is the end of this whisker. And then what happens is you get a median. And so the median of your data is the middle of the box and whisker plot. Or it's not technically the middle, but it's where this middle line is. It's the median. Then you do something interesting. After you do that, you do what's left over in the front, the data in the front. You take the median again, and that gets you quartile 1. And then you've got part of your box. Then you take your upper value, your upper half, find the median of that. That gets you your quartile 3. They call it quartile 1, median's quartile 2, and then quartile 3. Now what this does is it splits the data, and then you can finish your box and whisker plot. And you should have a number line below it to get the spacing right. But what's interesting about box and whisker plots is they show you where your data goes, or how it's concentrated. So every segment, every whisker, and every part of the box is 25% of your data. So it's interesting. So when you look at this, you can be like, oh man, 25% of the data was pretty compressed in this space here. It was a little more spread out here. So it's interesting. You can see where the data congregates. All right, so let's take, I guess we'll look at an example here. It says a box and whisker plot is one way to represent this data visually. So first things first is whenever you do a box and whisker plot, because it deals with medians, is you have to have everything in order. So we're going to take a moment. We're going to write everything in order here. Excuse me. All right, and now they're going to call this the 5-number summary, which sounds kind of interesting to me. But what we're going to do is we're going to find all the important things that we need to make our box and whisker plot. So first things first is our minimum number was 0. Max was 45, and then our median, so remember you want to go into the middle number. So we have, let's see, 1, 2, 3, there should be 24. So what we're going to have to do is go 12 in, and then that puts us at the inside of 10 here. So we're going to be between 10 and 10. So that means our median is going to be 10. And then what you do is take what's to the left and find the median of that. So we're gonna have 12 things here. Sometimes one of your numbers will be your median, and in which case you won't use it when you find the quartiles. But because our median was technically in between these two 10s, we're gonna count 10 and we're gonna count 0, and we're gonna go in the middle of those, so that would be 6 in. So we're between 3 and 5. So 3 plus 5 is 8, divided by 2 is 4. And we kind of knew that 4 was between 3 and 5. And then on the front half, same deal, we'll go 6 in. And yeah, we're going right between, and yeah, what's between 16 and 18? Well, 17 is. But also, if you forgot to find the median when it's in between, add them up, divide by 2, and you'll get your median there. So that 17 is quartile 3. So yeah, 0 is our minimum, quartile 1's 4, quartile 2 is our median of all the data, which was 10, quartile 3, and then the max. And then here's what it looks like when you make your box and whisker plot. And we can see that the information's pretty concentrated between 0 and 4, a little less concentrated between 4 and 10, a little less concentrated between 10 and 17, but it's really spread out seemingly between 17 and 45. And remember, 25% of the data, 25% of the data, 25% of the data, 25% of the data. All right, so let's flip this over and go over a little vocab. This vocab has always kind of thrown me off. When you have a longer whisker on one side, you say it's skewed to that side. So this is skewed left. And that seems doesn't quite seem right to me, but when it's skewed left, that actually means your data was more concentrated to the right. And I guess that kind of makes sense. It's skewing the data. And then symmetric's going to be balanced on both sides. And then if it's skewed right, that means the whisker on the right's going to be longer. And so that means your data is more concentrated to the left, more concentrated. Yeah, so there you have it. Now let's take a look at one here and actually do a box and whisker plot for ourselves. First things first, put the numbers in order. And let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9. So we should have a middle number. Our middle number is 7. So this time our median was 7. And then we get to ignore the 7 and then find the median of the lower half. So it'll be between 5 and 6. So it's 5.5. And you can add 5 and 6 together, divided by 2. And then ignore the 7 because that was our median. And then we go between 8 and 8, which is 8. And we're ready for our box and whisker plot. Draw a number line first from your minimum to your maximum, so 4 to 9. And then up above, put your dots at 9, a dot at 4 for your minimum and maximum. Draw a line at 7, your median. Draw a line at 5.5, which is your first quartile. Draw a line at 8, which is your third quartile. And then you're ready to complete your box and whisker plot. And that is how it's done. And a lot of times you'll see it where they'll write the values down across the top. Okay, so that's how you do a box and whisker plot. Not too bad, I don't think. And then let's talk about some information that you can glean from a box and whisker plot. It says the box and whisker plot represents the prices in dollars of soccer balls at different sporting goods stores. So we see the cheapest price was $8.50. The most expensive soccer ball was $24.50. And we can see things in between. The quartile was $11.25. The median, $15.75. The upper quartile was $20.25, quartile 3. And let's see if we can answer some information here. It says, find and interpret the range of the data. Okay, well, we haven't talked about that yet. The range of the data is when you take the largest amount and subtract the smallest amount. And in this case, we get a range of 16. Describe the distribution of the data. Okay, so I would say that it's pretty symmetric, slightly skewed right, which means that in actuality, the prices are more condensed towards the lower end of the spectrum. So I'd say skewed right just a bit. All right. And then find and interpret the interquartile range of the data. So the interquartile, what they're talking about is the box. So from quartile 1 to quartile 3, what's the range? So you'll go 20.25 minus 11.25, which gets you 9. And then finally, are the data more spread out below Q1? So here's Q1. Or above Q3? And we can see that from 8.5 to 11.2, they're that long. From Q3 to the end, it's longer. Yeah, it's totally longer. So, yep, more spread. Above Q3. And they say explain. And I'm going to say because the whisker is longer. And yeah, there we have it. Thanks for watching. Have a good day.